friends, okay? So keep doing that, respect each other, work as a team, and we celebrate every win, okay? If you do something good, or if your friend does something good, express your joy for that. Because that's what we do in our classroom. We learn from our mistake, we try our best, we create and inspire our friends. So don't put anybody down. If something didn't go right, motivate the person, okay, so they can do it better the next time. um and Dolores said, observation was, something that they learned. He learned something really important about the observation, and that is good. That's where we start. Okay, we start with observation. And can anybody tell me what hypothesis was from the last meeting? Can anybody tell me what hypothesis is? Okay, so we learn about observations and how to questions observations, and then we'll go to the hypothesis. Okay, the hypothesis is a scientific way that um, we derive those answers. We come up with answers, educational prediction, something that makes sense to fix the problem. Okay, so that's where we're gonna go. And the prediction we talked about was what, picking something out of the hypothesis and working on it and testing it, experimenting it. Okay, let's recap here. Scientific method from our last learning lesson is it's the core of biology and other science lies a problem solving approach called scientific method. Okay, so if you want to solve a problem scientifically, you want to use scientific method to solve your problem. Okay, when you see that there is a lot of disease in your community, you start by observation, seeing that problem, asking questions. Why is it in your community and not in the other community? Why, what started the disease? And when you do all those research, you come up with hypothesis, a testable explanation why, you know, maybe there's too many stagnant waters. Maybe there's a food poison or something. That you come up with reason, good reason to solve the reason why it is happening. Okay, you don't come up with something that is outside the explanation. Okay, you have to. It has to be very testable. Like if you say there there are diseases because there are foreign insects coming to the community, it's testable. You can find out what kind of for the last year or two has there been any foreign insect, foreign animals. Is something happening? You can test it. But if you come up with something that you cannot test, it's going to be hard for you to come up with a solution. So it has to be testable. Okay. Let me know if you are hearing me. Oh, please. Are you hearing me well? Can I get thumbs up? Okay, I'll take it as you are hearing me. Are we good? Everybody hearing me? Sadiq and Richard. I think it's just Sadiq and Richard right now.
Yes.
So when you do that, then you make a prediction for your hypothesis. Okay, you come up with explanations, and with the explanation, you pick one of them and say, okay, I want to go with it because our with our problem that we were solving, we were losing games, and we found two hypotheses or reason why we can, we were able to get on the winning side. And one of the reasons was what? Sign a striker, and the other one was change our team colors. And so once you establish that, you're going to have to take one of them, maybe sign a striker and work with it and test it and find out what it's going to be the solution to the problem. Okay. So once you predict that, okay, sign a striker is the is solution, then you use it as you test that, you experiment that. Okay. Now, what is hypothesis? It is it is a precise, testable statement of what the researchers predict will be the outcome of the study. Okay, so when we started, you say you observe. When you ask questions, you use different modes to ask questions. Either you can do your research online, or you can ask somebody, you can ask a teacher or a community leader. You don't just ask questions and leave it. You have to do that research. Okay, why is this happening? Then you do your research. From that research is what you're gonna come up with some predictions, hypothesis. So hypothesis is a group of predictions that you are going to embark on. Okay, when you find out the research reason why it's happening, you collect a couple of hypotheses. Okay, and that's where you start. Our hypothesis was we sign a striker or we change the team color. Okay, but our prediction was okay, definitely signing a striker. Sorry, my mind went. Can you hear me? Okay. Our prediction was signing a striker. That's what we predicted that it's going to be the solution to our problem. Okay. You predict what you think the answer will to your question might be. Okay. After you found all your research, these are the predictions that I want to go. These are the educated guesses that I want to, uh, 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 use for my solution. It must be a testable hypothesis. It cannot be something outside the solutions. Okay, that's why you do research. That's why you have to understand the meaning of what is going on. That's why you ask your questions. Okay, if you do that, then you come up with educated guess. If you don't learn, if you don't do research, the whatever that you are doing is obsolete. There's nothing. You can't do anything. Okay, you are just asking questions that everybody's asking, but you're not taking the initiative to understand why this is happening. That's where your research come in. You can go online and do your research. You can ask questions. You can read books. Then you come up with educated guess. Okay. Last time you guys were not hearing it, so hopefully, let me know if you hear it. Okay.
Please, we can't hear anything.
Okay. Um, Okay, I'm having the same problem from last week. So what I'll have you guys do is watch the video when you're done. It explains exactly what I'm saying, that you have an educated guess and you make a prediction. Okay, so this is the start of your experiment. Before you start your experiment, you need to have educated guess, and that means you have to read and explore and ask questions to have the right mindset, to have the reason why you want to do this. So hypothesis usually involves proposing a possible relationship between two variables. Okay, independent variable and dependent variable. Okay, independent is not. It doesn't depend on. It's like mostly it's research. What the research changes. Okay, it doesn't depend on what you are doing. Okay, so let's say you want to grow, you want to find out if a plant grows well under some certain condition. Okay, so there are dependent variables like soil and what do you call it, sunlight, you know, and all that comes in play to help. Okay, what so independent variable will be like watering the soil because it's not part of it. Okay, and dependent is the soil. Okay, is the plants and the sunlight. Okay, in research there is a convention that hypothesis is rated in two forms: the null hypothesis and the alternate hypothesis. Okay, and we will learn about these two. This will give you an idea of what kind of hypothesis that you have to write. Okay, once you do your research, do I need to go with the null hypothesis or do I need to go with the alternate hypothesis? Okay, that's what we're going to learn today. So alternate hypothesis state that there is a relationship between the two variables being stated. Okay, one variable has effect on the other. So there's a relationship. The two variables, the dependent and independent, there is a relationship. Okay, so let's state that um, the result are due to chances. The result are due to chance, and they are they are significant in terms of supporting your theory that you're investigating. Okay, so in alternate hypothesis, your relate the relationship between the variable and the relationship between the independent variable and the dependent variable uh, are the same. The two, it's there's an effect on the two variables. Okay, so growing a plant, right? The relationship with the dependent variable and independent uh, have something to do with each other. There's no you have to water the plant, water the soil to get the plant to grow. There's got to be the sunlight, part of it to help with the growth of the plant. Because if you keep it under your roof and there's no sunlight, it will not grow. We know that for sure. Okay, but when it comes to null hypothesis, um, it's something I think someone is trying to get in. When it comes to null hypothesis, there is no relationship. There's no relationship between the dependent variable and the independent variable. Okay, because I'm trying to find an example here. Hold on. So when it comes to a null hypothesis, I'm trying to think of an example here. All right, so let's say a researcher thinks that if a knee surgery, okay, hold on, let's see. The, let's say a researcher thinks that a knee surgery can help, uh, can help with the situation of a patient. Okay, all right. So for the null hypothesis here,
Benny, okay?
Oh, sorry. So you're not hearing me?
No.
Oh, I mistakenly hit uh the space button. Sorry. Oh, so you guys were not hearing me. Um, Let me go over again. So did you guys hear the alternate hypothesis and null hypothesis that I gave? I'm trying to see where. How long was it?
I'll say a minute.
Okay, so the null hypothesis, there is no relationship between the measure phenomenon, the dependent variable, and the independent variable. So the dependent variable and the independent variable do not have any relationship. Okay, you do not need to believe that null hypothesis is true to test it. Okay, on the contrary, you will likely, suspect that there is a relationship between a set of variables that you're not really sure. But one way to prove this is to reject the null. Well, the one way to prove this, is to reject the null hypothesis. There's a relationship, but you're not really sure. So, like rejecting null hypothesis doesn't mean that the experiment is bad. You just that okay. I've picked up this hypothesis, but I'm not really sure if it's gonna work or not. Okay, I understand that it might there's no relationship between the variable and the independent and dependent variables, but it doesn't necessarily mean that my hypothesis is wrong. There might be a relationship, but I'm not really sure. So that's where the null hypothesis comes in. So most of the time, you want to be more of a alternate hypothesis. There's got to be relationships to see the results. Okay, that it has to be supported. That what you the research, it all depends on the research that you do in the beginning. What if you found out that there's enough relationship between the dependent and the independent, that's good. That's the alternative that you can go with it. But sometimes it's very hard to find the relationship between those dependent variables and independent variables. So it doesn't necessarily mean that it's wrong. It's just that it's not there. But you can still go ahead and test it. Okay. um, I think the best way to do null hypothesis is just start asking questions, doing your research. Make sure that there is a relationship. Okay. Maybe you asked the question wrong. So rephrase the question and find out even if you Googling it, sometimes you might not ask the right question on Google. Or even if you ask the right questions, people don't have the right answers to do. It doesn't mean that it's wrong. It's just that there's nothing there. And that's what null means. There's nothing there. But you can go ahead and do your research. Last week we said that not every research is bad. Okay. Sometimes that research will give a leg up to other researchers to know that this is not good. So it's not necessarily bad to do a null hypothesis. There's no relationship, but go ahead and start it. We'll skip the video because you guys are not able to hear it. Now, once you have your hypothesis, then you have to make a prediction and test the prediction. And that's where the experiment comes in. Okay. So I have maybe I use an alternate hypothesis and I was able to find a very good research about the hypothesis. So let me go ahead and start testing it. Okay. Even if you have a null hypothesis, you can still go ahead and test it. There's nothing wrong with it. Okay. So our with our problem of not scoring enough goals, our hypothesis had an alternate hypothesis, which is a dependent variable of a striker. A striker is part of the group, is part of the team. If we think changing a striker is good, it will make a difference. We're gonna go ahead and test that. That's an alternate hypothesis because there is a relationship. Now, when it comes to the colors of the team, It's not necessarily, there's no experiment out there that shows that when you change the colors of your team, you are actually going to win. We don't have a good relationship with the variable, the dependent variable and the independent variable. There's no relationship, but we still want to go ahead and try it. Maybe we will find a solution that nobody has found it. So it's not necessarily a bad idea to test a null hypothesis, which is the colors of the team. Okay. All right. So I'm going to give you an example of hypothesis, the difference between hypothesis and a prediction. Okay. Because it can be confusing. You when you're doing a hypothesis, you've done your research and you've got a couple of workable, maybe null or high alternate hypothesis. But what is a prediction? Okay, a prediction here. Okay, so let's say a flashlight doesn't work. Our hypothesis, our research say it could be a battery dead, it could be a bulb ran out, died. That's the two hypotheses that we came up with. The prediction is taking one of them and working with it. Okay, so we're gonna predict that from between the two. Okay, we're gonna predict that between the two, one of them will work. Okay, so let's take the first one, the batteries. Let's just replace the batteries of the flashlight and see if it'll work. Okay, because we don't know. We've done our research and we know that it might work, but we don't know for sure. Once we test that hypothesis, it's and the light comes on, then we know that our first hypothesis, our first prediction was good. We predicted that the first one would be good. We could maybe when we predict the first one, the first hypothesis, we might not get the answer. We might not, it might not be a good solution, but doesn't mean that it's wrong. It's just that we need to make another prediction. Okay, so a prediction is when you have all your hypotheses and you make an educated guess. You make a prediction. This is what is going to happen. Okay, so may know the difference, please. Okay, know the difference. Know that your hypothesis is based on your research and your questions, and you don't have just one reason to or one solution. You have multiple. So your prediction is taking one of them and saying, okay, this makes sense. This is what is going to happen. If we sign a striker, we're going to win. This is, I know, for your heart that if you sign a striker, we're going to win, and that's a prediction. You predicted it. But we also have another hypothesis, changing the team colors. We don't know that for sure, but we are sure that our first prediction is going to work. So to learn the difference between predictions and hypothesis, okay? It's very important. All right. So once you have your hypothesis, then you make your prediction and you make your experiment. Always record your result of your experiment, okay? That is very important. So the important part of our solution is making an observation. We learned last week, observation, asking questions, doing your research, okay? Finding out the reason why it's happening, and you create a hypothesis. Your hypothesis can be an alternate hypothesis or a null hypothesis. Alternate has relationship between the variables, independent variables and dependent variables. The null does not have any relationship. That's why it's called null. There's no relationship. Okay, but it doesn't mean that it's wrong. Okay, so once you do that, then you make your prediction. You can most likely you're gonna pick what that alternate hypothesis because there is a relationship. But if there is no relationship, you can also go with a null hypothesis. It doesn't mean that it's wrong. Once you do that, you do your experiment, you have to put in the work, test it, sign a striker, let's play the game and see if it's gonna work. Then you analyze the results, see which one is right or which one is not right. If it's true that we sign a striker, we're gonna win. At the end of the game, we will win. We know the results. Okay. If it's supported, then we report the result. We say, okay, we won the game. If it's not supported, we could also record it, or we can try it again. We can record it and try it again. Okay. And we test another hypothesis. Maybe we choose a null hypothesis this time and see if we are able to wear a different jersey, we will win this game. Okay. Do you understand? Any questions?
No.
Okay. Please let me know if you have questions. All right, so we're going to do a test right now, an exercise, okay? The first one, we all do it together, okay? There is a problem. The problem is a fish farm operator noticed that the baby fish are not surviving to adulthood. They are dying. That's the problem. You work, this is your work. You go to work and you see the baby fishes are not surviving. They don't live long for you to have your adult fish. So that's the problem. Now, okay, what's the meaning of prediction? All right. Let me go back here. Okay, so prediction is you selecting one of the hypotheses. Okay, let's go back here. All right, so you see do you see what my screen? The hypothesis comes from what you study, what your research is. If you go on Google, if you ask questions, if you do some research, you come up with an explanation of why this is happening. You don't come up with just one, and that is your hypothesis. Your hypothesis is the different explanations. Okay, it might be a dead battery, it might be the bulb burned out. Taking that one prediction, one hypothesis is what is the prediction. Okay, so the two high explanation. Now I want to take one. I predicted the first one will work, and that's your prediction. That's the explanation for your prediction. Taking one of the hypotheses and working with it is the prediction. Does it make sense? Your prediction is selecting one of them. Okay, your predictions is selecting one of them. Okay, does it make sense? You are predicting that this is going to work. You are predicting that the battery is the answer. Okay. All right. And if you go back to our previous lesson, you will find the explanation for prediction. Okay. But predictions is just taking one of your explanations. Yeah, you can form as many hypotheses. It's all educated guess because, okay, I don't know why the battery is not, the flashlight is not working. There's so many reasons that it could. It could be that it's old. It's the whole thing is old. It could be that the bulb is out. It could be that the battery is out. There's so many predictions. So hypothesis is a lot of predictions, but prediction is taking one of them and working with it, saying, okay, let me do the experiment, because you can't do all the experiment at the same time. So you take one as a prediction. I predict that the battery is the reason why this is not working. So I'm going to take it and start working and finding out making it doing an experiment and finding out that it works or not. Okay, so see the difference. You can have predictions is a lot of hypothesis. Okay, and a prediction is hypothesis is a lot of predictions. Okay, sorry, hypothesis is a lot of predictions. Prediction is taking one of them and working with it. Okay. All right, thanks for that question. Now, okay, so everything that we've learned, we want to make sure that we know the different stages of the problem and the solution. Okay, the fish farm operator saw that the baby fish are not surviving out of the hoop. Okay, it's a problem because they need to grow up so they can be able to harvest those fish. Okay, that's a good question. What if the hypothesis I made was wrong? Now you come back to what we were talking about. Okay, if the hypothesis is wrong, it's not supported, there are two things that you can do. You can report, you have to report that it did not work, so somebody else does not waste their time to do that research again. Okay, you have to make sure that you write it down that did not work. Then you go back and try it again. You try another hypothesis. That's why you have more than one hypothesis. Okay, we have two. In our case, we have two hypotheses. We have a striker and the jersey, the colors of our jersey. So taking one of them is the prediction. Taking one of the hypotheses is the prediction. We went through that prediction, it did not work. So we come back again and take the next prediction. Okay, do you understand? When it's wrong, it doesn't mean that it's wrong. It's actually a good thing. It eliminates that part of it so that nobody will, bother themselves testing that again. Okay, so when it's wrong, go ahead and report. But also go back to your list of hypotheses and choose another one. Okay, you don't have to give up. When it's wrong, doesn't mean that you don't have any. That's why you have a lot of hypotheses. You have to create more than one hypothesis. So when one is wrong, you go back here and choose another one. Okay, does it make sense? Now you see. Okay, let me know if you have any more questions. I like that. Okay, let me know if you have any more questions. Okay, so we go over again. You make your observation. We have our different kinds of observations. And once you make your observations, you do your research, you ask questions, you do Google, you talk to people that know subject matter experts. And once you're done that, you take the different reasons, explanations why it could happen, the reason why we are losing, why are we losing again? We need a good striker. Our team colors are bad. There could be more. Okay, so once you have those down as a hypothesis, then you take one. Taking one of them is called prediction. Once I say I want to take the striker as having a good striker as a solution, then I'm predicting. Okay, and once you predict, you do your experiment, you test the prediction, and once the results come in, if it's good, if we are winning games, then yeah. If we are not, we'll try it again. But we also have to make sure that we know why we did it, why it was wrong. Okay. All right. So let's come back to our problem here. That the fishes are not growing up. We need them to grow up. So she goes to the library and looks up what fish needs to do to survive. That's your research. That's your asking questions. What fish need to survive? That's a question. Okay, you're gonna have to do some research and make sure that you know reason why. Now she has a couple of hypotheses. She thinks that the fishes are not surviving because there is not enough oxygen in the water. Okay, that's her hypothesis for now. See, that's hypothesis. Now, to make sure that the hypothesis is right, she's gonna have to make a prediction out of the different hypotheses that she came up with. She didn't come up with one; it was more than one. So she takes that one hypothesis and now she tests it, and that's where the prediction comes in. Taking one hypothesis is your prediction. Okay, the oxygen the higher oxygen group, so now now when you are having experiments, now we have the control group, and so the control group is what you are, the everyday life. It's the people that the fishes that are dying. We are not doing anything about it. Okay, and then you take the other group that you increase the oxygen part of it, and then you see that, okay, when I compare the experiment to the control group, what happens? Maybe more fishes die, or maybe they survive. Okay, then now you know that there is a difference. Okay, you have to always have your control group. There is a difference between the people that the fishes that survive. Yeah, we need a new striker. That's going to be the reason why. So when we tested, we realized that we need a new striker. So our result is more fish survive because we change, there's a change and there's a control group. The change is what we are testing, is our hypothesis. The change is the more oxygen. The control group is we're not making any changes. We want to compare if this works or not. Okay, so we concluded that more oxygen, that lack of oxygen is what causes death. Now we are publishing our results. Okay, that's the conclusion. Okay, do you understand? Can you give me a thumbs up if you understand what I'm saying? So this is our experiment. Our experiment is we found a problem. Then we do a research, ask questions. Then we come up with different hypotheses, reason why it's not working. Then we predict it. When we predict it, we have to what? Do an experiment. You can't just predict and leave it. You have to do an experiment. Then we'll see whether it's good or bad. Then we know that we are doing the right thing. Yeah, Michael, it's very true. It's true that you can say that the food that they are eating is the reason why they are not growing. But that's part of your hypothesis. Okay, so you're going to have more than one. You think there's an oxygen problem, you think it's a food, you think it's the environment, there's too much sunlight. These are your hypotheses. Okay, now the prediction is taking one of them and using and experimenting on it. That's your prediction. Okay, your experiment is your prediction. So maybe if we test that they're not having enough food, maybe it could be right, it could be wrong. We don't know. But one thing we know for sure right now is we test our first. You want to test your first prediction, your first hypothesis, the one that you think for sure it's going to happen, is going to solve the problem. Because you don't want to be testing over and over again. The idea is to have a green light. When you analyze the result, then it's good to go. You don't want to have a bad result, then come back again and do it. It's too much work. You want to do the one that makes sense the most. Okay, that's why you test your educated, you have your educated guest. So we're going to do the same work. Okay, this is going to be the same work, and we have gonna have a problem. You identify what the problem is. You identify which one is the research, the questions answered. Okay, the questions that you ask. You identify which one is the hypothesis. Identify which one is the prediction, and the result and the conclusion. Okay, so that's gonna be our homework. Can I be self-dependent during the scientific method of solving problem? Yeah. No, see, as a scientist, you have all different options. Okay, if you think that you can do it by yourself, that's fine. But science is a community, so that's why when you record your results, you have to post it. You have to let everybody know the results. That's where the community comes in. Okay, so that somebody else will not go back and do the same and make the same mistake. So that's why it's a community, but you can also solve the problem yourself. Prediction is the same as experiment. Okay, so once, let's go back to this screen here. Okay, so once prediction is taking one of the hypotheses, the explanation, taking one of them and saying that this is the right answer. So when I predict, it means that of all the explanations that I gave, of all the hypotheses, this is the right one. I'm confident this is it. So then I go through the experiment. The experiment is that I'm taking one prediction and I'm working with it. Yep, experiment and prediction goes hand in hand. You have to test your prediction. This is if I choose this explanation, I have to test it, and that's my experiment. Okay, how are we doing so far? What do you guys think? Is there any comments? Anybody wants to say anything or questions? Keep the questions coming. Okay, good job. Keep the questions coming. So your homework is to identify um, which of these problems is which of these statements. Okay, so this is your homework. These are not arranged um, as these are not arranged. Okay, it's all over. The statements here are not uh, according to problems and solutions. Okay, let's take the first one. After a month, Jane measured the plant and finds that the plant grown under the red light is 5 centimeters tall. Okay, so Jane what measures? Measure is what? Experiment. Jane did the experiment. So this first statement is the experiment. Okay, okay. So Jane measured. Now you have to pay attention to what the statement is saying. Okay, Jane measured is not observation. Jane measured is not conclusion. It's not a prediction. Is she measures the plan. That means it's what the experiment stage. This is the experiment stage. Okay. All right. So the second statement is she looks up the different colors of light to see if there might be another option for the light color. She looks up. That means that she's what do you call researching. She's asking questions, researching. Okay, that's the research stage. Okay, so you go according to every statement, whether this is the research, this is the experiment stage, a research stage, or the observation stage. So these are the stages. Okay, so you have to match all these stages to the different statements. Okay, that's your homework. Okay, this is one, this is two. Okay, match. If you read a statement, what do you think is the statement is? Is it an observation? Is it a research? Is it conclusion? Is it hypothesis? Then you write it next to it that this is hypothesis, this is observation, this is, let's do the third one. Jane noticed her plants are not growing well under the white light. She noticed, that is observation. She noticed. Okay, so this is an observation. Okay, this is, she looks up the different colors. That means she's doing research. Okay, this is, she measures. That means she's doing experiment. Okay. Please use the scientific method to solve this problem. The people in Nigeria are suffering from cholera. Okay. All right. So let's do this. What do you think is the observation part of this statement? What's someone tell me the observation part of this statement? We're gonna go. Okay, we're gonna do this together. Okay. What is the observation part of the statement? The people in Nigeria, Ghana are suffering from cholera. What's the observation? What do you think the observation is? Okay, the people are suffering. That's the observation. We observe that things are not right. That's the observation. The people are suffering. What do you think what are some of the questions that we can, what are some of the research that we can do? What are the questions that we can come up with? Why are they suffering from cholera? Give me some research, some hypothesis. Yep, they have a dirty environment. That's one. Keep coming. They have a dirty environment. That's might be the reason.
They don't practice personal hygiene.
They don't do what? Say that again. Okay, so they don't eat hot meal. That's a good one. We keep coming with the hypothesis. So we're going to have more than one hypothesis. Okay, we have all these hypotheses. We're going to gather all of them. Okay, then we come up with a prediction. After we have all these hypotheses, then we're going to come up with a prediction. Why they don't practice personal hygiene? That's good. These are all hypotheses. Why are they having cholera? These might be the reason. Okay, we don't know yet, but we know for sure from our research that they have polluted drinking water. That could be it, but we don't know. Unless we make a prediction, then we can go ahead and do an experiment on that hypothesis. Okay. Do you get what we are trying to do here? You find a problem, you observe the problem, you do a research. Okay. You don't just do any research. You want to make sure that all your hypotheses make sense. Okay. And that's what we've been doing. They have a dirty environment. They don't eat hot meal. They practice they don't practice personal hygiene, polluted drinking water. That could be it, but we have to take one. Taking one of them is the prediction. Once we make the prediction based on the hypothesis, then we test the prediction. Let's say they don't have, they have polluted drinking water. That's what we're going to go with. We don't know if it's true or not, but we go with it for now. So once we predict that, we'll do the test. We'll test the waters. We have a control group. And we have a change. We let people stop drinking that water, and the other people that are drinking, we'll compare it to the people that are not drinking. Then we'll see if they are getting there's cholera. Okay. Then we see there is a disease. If that's why you have a control group and you have a change. Okay, that's where the experiment comes in. And once we analyze the results, and it's true that the drinking water is the reason why they are getting this disease, then we know we stop it. We will fix the problem. But if we find out that even if they don't drink the water, they're still getting the disease, we have to go back again and take another hypothesis. We have to go back and take another hypothesis and start doing it will start with another prediction and experiment. So this is good. Okay, this is good. I want you guys to do that, do observation, write about the hypothesis, and write about a prediction. Once you predict it, let's do an experiment. Okay, so that's going to be one of your homework. Not only that find out which of these results and hypothesis and research and problem, but also come up with your own observation. Come up with some observation, and let's work with it. Okay, all right. You guys are doing very, very well. Thank you so much. This was really good. I hope you learned something. Okay, so this week's homework is identifying which of these statements is observation, which of them is hypothesis, which of them is research or prediction or conclusion. Okay, you are doing very, very well. Thank you so much. Thank you. Um, any more questions? Any more questions? Keep your questions coming, okay? And if you think of any more questions, just email me or text, WhatsApp me, okay? But this is what we want to do, okay? This is what we want to do. This chart, always have this chart if you are solving a problem. Okay, if you make an observation, start with your answering questions, making a list of hypotheses, predict which one will be right or not right. Then go with an experiment, analyze it, and report. Okay, how are we doing? All right. All right. So today, this is all for today. Let me know if you have any questions. Sadiq and Richard, you guys are doing a fabulous work. Let me know if you have any questions, okay? We appreciate all the work that you're doing, and let's keep these students engaged. And these are future scientists. You're gonna solve problems in your community, okay? All right. So good job, all you guys, Sadiq, everybody.
Hello, Ben.
Yeah.
Yeah, with the previous assignment, is this scientific method? The one they were to drag the QI and the QN.
Uh-huh.
Yeah, some of them have tried, it worked, but others, it's not working. One student for the past 3 days, he has been dragging and dragging and dragging, and the thing is not moving.
Okay, well, do this for me. Why don't you take a pen and paper and write it down, okay? And take a picture and send it to me, okay?
Oh, okay.
Take a pen and
Okay.
paper, write it down, fill in the question for answers, and send it, okay? Sometimes
Okay.
it's hard to do that. So yeah, just do that and send it to us, okay?
Okay.
All right. Yeah, is there any more questions? I know you guys are doing your best over there. Thank you for all that you are doing, and your reward will come soon, okay? All right. Any more questions? Okay. All right. Well, we'll end today, and just if you have any questions, just send it my way, okay? Take care. Be good. Um, we are working so hard to help this trip to Ghana, so we can have a community. All right. Thank you. Have a good day. Have a blessed day. Bye.